Hi everybody, this is Nafish. In today's lecture, we are going to learn how can we rotate an image, how can we flip an image, and how can we transform an image. Okay, so let's get started. First of all, we have to import CV2 as CV. Okay, and then run it, and then let's import our image. So img, the variable we're going to keep the image in. So img is equals to CV dot im read, and then we have to name that image. So that is card game 29. That's the image I'm going to get in, and then one. So we're going to have on the color. Okay, so run it, and let's import matplotlib as well. Import matplotlib.pyplot as plt, because we are going to display that image here. So plt.imshow and show, and then name of that image, that is img, right? So let's run it, and this is the image we have. But since I haven't converted the color, because in matplotlib the color code is RGB, but since we are reading that image in um, opencv, that is BGR, so they are in different color channel, so we have to do a conversion here. So the way we can do it is img RGB is nothing but equals to um, convert color, so cv dot cvt, which is convert color, and then the input is img, right, that image, and then we have to call cv dot color in caps, and then rg bgr to rgb. Okay, and here I have to put a dot. Okay, so let's run this line, and then there is no change in color because I haven't changed the variable name here, so it's going to be img RGB. So now the color should change. Okay, so this is the original color. So basically now we are going to try rotating this image. Okay, so to do that, let's say img, let's say we are going to rotate 90 degrees, right? So 90 is equals to cv dot, let's call the rotate function right there, and then the input is img RGB, right, the original image, and then we are going to rotate it 90 degrees, let's say. Okay, so for that, cv dot caps rotate, all in caps, so right there, so clockwise 90 degrees, right? So you run it, and let's do some more rotation as well. So oops, let's copy this guy and then paste it below two more times. Okay, I'm just going to tell you why. So one is 90-degree rotation, then we have, let's say, 180-degree rotation. Okay, so if you just erase this guy right here and then press tab, rotate right there, 180 rotation. Okay, so now we have gotten 180, and this is another one we can do like, so first one is clockwise, and we can do the anti-clockwise or counterclockwise. So counterclockwise cc, let's give the name to that variable, and then you just erase up to this portion and then press tab, and you will see counterclockwise. Okay, so we have four variables. One is the original image, which which is only, which is in RGB color, right? RGB, and then we did some rotation. So one is 90-degree clockwise, then 180-degree, and then 90-degree counterclockwise. And let's visualize all these four variables. Okay, so we have PLT right here, and this is the original image, right? So let's copy this and then paste three more times. Okay, so we have RGB, then 90, then RGB 180, and then we have RGB 90 clockwise. So RGB 90, and then counterclockwise, sorry. Okay, and we have to call a subplot, so plt dot subplot, so that we can visualize all the images together. So we have four images, right? So we need two columns and two rows. That will give us four spots. So two column, two rows, and then the first element is the original image. Okay, then copy this guy, and the second element is going to be the 90-degree rotated image, third one is going to be the 180, okay, and the fourth one is going to be the counterclockwise, okay. So if we run this, oh, we haven't run this portion, so we have to run this and then run this guy. And now you see we have the original image right here, then that is 90-degree rotated, and then we have 180, so just 180-degree of this guy, and then we have counterclockwise rotation, okay, which is 180-degree of this 90-degree, okay. So this is the way you can rotate that image. I would like to show one more thing, that is flipping that image. That will be a little bit different, okay. So let's copy this guy right here. So we have this original image, right? So let's say image RGB, and then the variable name is flip. Let's say we call it flip, and then we flip this original image, okay. So CV dot flip, okay, and then we have this original image is img RGB, and then 0. So 0 flip. So if the parameter is 0, I will show you how this will look like, okay. So let's plot these two variables, okay. We can just in fact copy from right here, okay, these two lines, and plot this side by side. So we have in the first one, and this is the, so we just need one column because we're just going to show two pictures, right? One is the original one, one is the flipped one. So this is the RGB one and this is the flip, okay. So let's run this. Okay, so this is the first one, the original one, and the flipped one. So 0 is vertically, okay, so you are flipping it vertically, but this is going to be a mirror of the original image, okay. So this is the difference between flipping and rotating. So when you are rotating, remember here you are doing then 180-degree rotation of this guy, right? This is not a mirror image, but here this is a mirror one. So this is in the vertical um, direction. You can also do, I think one is horizontal. So let's see how it looks like. You see, that is different. You can also do -1, which is both vertical and horizontal direction. And I think this is going to be like 180-degree, I think. Yep, right there. Because you are mirroring two times. So that's why you are just um, having just opposite 180 of the original image. So flipping is different than rotating. It's kind of a mirror, okay? And then you have directions. So -1 is, as I mentioned, both vertical and horizontal, flipping and then doing the mirror, okay? So this is done. Another thing I would like to go with, which is affine transformation. So for that, we need to, so first of all, why do we need this affine transformation, okay? Um, affine transformation. So we need this to do some correction in the distorted images, okay. So we grab images, using satellite, using the cameras in our car, different means, and sometimes the errors are, the images are distorted or geometrically. So we just need to do some transformation to get the desired image, okay. So let's see how this looks like. So first of all, we need to, so we have this image right here, img, and let's get the rows and columns of this image. So shape, so we know that 0 is our row, and then we have our column, that is 1, right? So this is row and column of the image we are working on, okay. So we have gotten that, and then we have to select 3 positions, okay. So let's say like 1, 2, 3 of that image, okay, the image we are working on. So let's say uh, current, okay. So here we got to select um, 3 locations. So np dot, and that's, we have to convert that into float, okay. So we need to, so let's select like 0 0, for example, 0 and 0, and then let's say select this position, which is um, 0 and col -1. So column -1, this one row is 0 here, right? And if you move and go to the very last element, there's going to be still row 0, but column -1 because we are starting from 0, right? And then let's say we are going to get this one, so that is row -1 and then column 0, okay. So this is our, this is that 1 2 3 points we are going to select, okay. np, we haven't import numpy yet, so import numpy as np, okay. And then the image we are going to create after the transformation, we have to define the points as well. Okay, so future, there's a future image, we have to define those. One thing I just want to mention is like the attribute of this affine transformation is one is like, um, the the lines, the parallel, affine means parallel, right? Parallel lines in the source image will be parallel in the generated image. Okay, so it's parallel, right? Affine is parallel. So in one plane, if it is parallel, the other plane there's lines going to be also parallel. Okay, so now I think if I run, oh, I need to change this point. So remember we selected one point, second point, third point, and for future, let's say we change it a bit. So let's say we we swap this part right here. I don't know what it's going to do, but just just change it. Okay, so this goes here and this comes here. Okay, so this is our future, right? This is not okay. Now there is no error because I didn't run this cell. Okay, so now we have to create a matrix that's going to be a 3 by 3 matrix from these two inputs. So I'm just naming it variable m and then call. So I think it's cv dot get affine right there. Okay, and the input is current points and future points. Okay, so run it, and as I mentioned, this is going to be a 2 by 3. Okay, 2 rows, 3 columns. Okay, so we got the matrix from the points we described, right? From the current plane and the future plane. Now we have to get the new image. So let's say new image is, we have to call cv dot rep affine, cv dot rep, why it's not coming out, cv dot rep affine right there, and then the first input, that is the image we're going to work on, which is img, and the second one is our matrix m, and the third one is our row and column, but changing changing means like changing the order. So column is going to be the first and then the row. Okay, okay, so I think we got it. Let's run it. Let's visualize that image, vlt dot im show, and then the input is new image. Run it. Okay, you see the image got changed, and also like the color, I didn't input that img here. You see I have to put rgb or else the color will be messed up. So rgb. Okay, now this should be fine. Run it again and run it. Okay, you see how the image got transformed. Okay, so basically it's keeping, so remember we didn't change one point, this one, so it kept those two same, but the other two got swapped, so it just swap those points, but that way we're just missing some portion. You can just change the numbers here, and let's say like 200, put 50 here and try to see how it moves. Okay, you see the rotation. So this is the way basically we can just change or transform the image. Let's try some more numbers. Let's say this guy. So run it, run it, run it. Okay, so this is the way we can transform that, the original image. And I also already mentioned the use case. It's basically to correct the distorted images. CV